Now, what you basically want to do here is just distribute. Here, hold on. Let me help you out. Oh, no. You want to distribute the 4 root 2 to both of those terms. So what is that times that?
12. And then root 12.
Okay, good. We can simplify it later. Minus what?
Minus 12 root 4.
Now, what's root 12 equal to?
3 and 4.
So it's 12. I'm going to put the 4 first because I want to take a whole number out. So what's that equal to?
24 root 3.
Okay. What's this equal to?
24.
Okay. And that's as good an answer as anything.
Yeah.
You could also, if you wanted, factor out a 24 and you're left with square root of 3 minus 1. But there's no real reason to do that.
Okay.
All right. This next one is a system of equations. Let me write it. And notice the first thing you should notice is that it is in standard format. It's not in slope-intercept. It's not in point-slope. There's basically 3 formats. Slope-intercept, y equal mx plus b. Point-slope, which we've talked about before, I believe. And then standard format. Whenever you see it in standard format, it's always going to be most easily solved by elimination. What do I do to eliminate a variable?
Multiply the top one by 3. Oh, we know because
That wouldn't help, notice.
because the 2y and the 2y.
Yeah, I can eliminate a variable without doing anything except adding the 2 equations.
Yeah.
So that's what I'm going to do. I'm going to add them. What do you get when you add them?
7x equals negative 14.
Okay. So x equals minus 2. Now how do you get y?
Y equals negative 2.
Yeah, well, hold on. If I go, which equation did you use to plug it into?
The top one.
Probably the bottom one is easier. Why would that be? Maybe not. Maybe not. I said that because I'm looking at a bunch of smaller numbers in the bottom one. I'm looking at a 3, a 2, and a 4. But it's also important that if I'm going to solve for y, I want the coefficient to be positive. And in the first equation, y does have a positive coefficient. So it turns into minus 8 plus 2y equals minus 10. So 2y equals minus 2, y equals minus 1. So the solution always, did I do something wrong?
Sorry, what?
Is that what you got also, y equals minus 1?
Yeah.
Okay. And if we just, if you were betting your life on this, you'd want to go back and at least plug it into one of them. Well, if I plug it into the second one, because I used the first one to calculate y, I'm going to check it by plugging into the second one. So I got 3 times minus 2 minus 2 times minus 1. Is that equal to minus 4? Well, that's minus 6 plus 2 equals minus 4. So both my solutions work. All right, I assume we want to go to the second page now,
Yes.
which is this page. Well, I would love to know how to get rid of the borders and everything. All the stuff they put on top of this covers up the photo, like this junk down here at the bottom.
Yeah.
Yeah, I don't know how to not have it be shown. But anyway, I can barely read the first
It,
on this page. What is
the very,
what what
sorry,
what is it asking?
it's indicate which of the following diptych functions.
Depict function?
Yeah.
And we're just worried about B and C?
Well, A is in parentheses 2, 3, comma 5, 7.
I'm sorry.
Well, like
What is A?
it's like brackets for braces. It's in parentheses 2, comma 3. Comma, then in parentheses 5, comma 7. Close parentheses, then comma, then parentheses 4, 6, and end of brackets.
Okay. So if I were to graph those 3 points, there's 2 comma 3, there's 5 comma 7, and there's 4 comma 6.
Yes.
So it's not a function. In other words, I can't really connect those, because all they gave us was 3 points.
Mm-hmm.
But do those 3 points make up a function?
Yes.
Yeah. The only way they wouldn't is if they would have given us, let's see, if they would have told us 2 comma 4, then I would have had to plot that right there, which is directly above the previous point, violates the vertical line test. So that's all you need to really look for when you have 3 points, is to make sure you don't have one value of x and 2 values of y. And if this was 2 comma 4, I would. In other words, for the value of x equal 2, I got 2 different values for y. I got a 3 and a 4. Well, that violates the rules of a function.
Yeah.
Now, on B, is the left oval labeled x and the right one y?
It's not labeled.
Not labeled at all.
No, but the arrows.
Okay. So what they're saying is, I believe, oh, now I can see the top. That is really weird how, I wonder what happens if I X that. Now I can't see the top anymore. Huh.
Oh, that's...
How weird is this? All right, so I presume what they're saying is there are 3 points, and the points are 4 comma 5, 2 comma 7, and 6 comma 5. Is that a function?
Yes.
Even though it gets a little tricky, notice that we have 2 y's that are the same. But what you're looking for is 2 x's that are the same with different y values, and we do not have that. In other words, if I plot these points, there's my 4, 5, there's my 2, 7, and my 6, 5 just goes right there. So they connect horizontally, but that's okay. If I were to connect those, that's a function. It passes the vertical line test. And basically you're looking for the 3 dots to pass the vertical line test. And they do. How about C? Is that a function? Is that all they're asking? Indicate which of the following depict functions. Okay. Well, 1 did, B did, does C?
Yeah, because it passes the vertical line test.
Yeah. Is it one-to-one function? Have you learned that yet?
No.
One-to-one function means it has to pass the vertical line test and the horizontal line test. So C would not be one-to-one. But it does pass the vertical line test, so it is a function by the definition of function. It's just not one-to-one. And the consequences of not being one-to-one are that you can't do an inverse of it. If a function is not one-to-one, you can't find its inverse. Or I should say the inverse is not going to be a function. You could write the inverse, but it would not be a function.
Okay.
Instructions look like they say find the volume of the pyramid.
Yes.
Okay. What's the formula for the volume of a pyramid?
1/3 over the base times the height.
Good. It's always 1/3 if it goes to a point. If it was a square, if it was a square all the way up, then it would just be base times height for the volume. In other words, if it was a rectangular brick, which is what I call a rectangular solid. Okay? So whenever it goes to a point, it's always 1/3, and that includes a cone. In other words, if you want to memorize the volume of a cone, it's the volume of the cylinder I know what volumes of cylinders are, and that's the base times the height, but since it goes to a point, it's 1/3 base times height. So that's the way I always memorize these things that go to a point.
Okay.
Okay. What is the base? Why is this a problem? In other words, why are they giving you this? All right. I thought maybe I was missing something. What's the base total?
400.
And the height?
18.
Cross that with that. Make that 6. 2400 is the volume. What are the units?
Meters cubed.
Correct. Cubic meters. Volume is always cubic. Area is always square. And lines are always meters only. What's the formula for the volume of a sphere?
I don't know.
It's 4/3 pi r. What would the exponent on the r be?
Squared?
Cubed. Remember that we want our answer to come out in cubic meters, right? So it's got to be r cubed. That's the only way we're going to get cubic meters. So the volume is 4/3 pi. 5 cubed is 125. So whatever that number comes out to be.
Okay.
I guess 500 pi over 3.
Okay.
That's its volume. Now, its surface area is 4 pi r. What should that exponent be?
Squared.
Yeah, the units of surface area are the same units as just area. So even if you're talking about a round surface area or a spherical surface area, the units are going to be squared. In other words, that's the same as when we talk about area of a rectangle, despite the fact that it's on a curved surface. So what is this surface area going to be? 4 pi times 25 or 100 pi.
Okay.
Meters squared.
Okay.
All right. 18. Give us 5 functions. And below are 5 shapes. Here, let me see if I can blow this up just a little. No, I can't even do that. Okay. Usually I can figure out how to zoom in and zoom out, but I can't on this one. All right. What shape is the first function? What is that? Oh, that's x cubed plus 5. Let's not talk about that one yet.
Okay.
Let's talk about the second function, g of x. Which one is that? It's quadratic, right?
Yeah.
What do quadratics look like? Parabolas. Which is the parabola?
C.
Yep. And it even matches. We know that if the x squared has a positive sign in front of it, it's a parabola that opens up. If it's got a negative sign in front of it, it's a parabola that opens down. So G definitely goes with C. Now how about H? Square root of x. Which one is that?
D.
Yep. In other words, square root of x looks just like that. It starts at 0 and goes up like that.
Okay.
Notice that x has to be positive. You can only take the square root of positive numbers or 0. And y has to be positive. Because when you take the square root of any number, the answer is always positive. And that's why it starts with a closed dot there, because x can be equal to 0. Okay? Now, on E, the figure E, we see a V. What functions create V's like that?
Plus positive?
Absolute value functions.
Okay.
Okay, in other words, if I were to plot this, just y equal absolute value of x, it gives you that V. Because notice when x is negative, the slope's got to be -1, but when x is positive, the slope's got to be +1. So you end up with a V. So the moment I see that V, I'm looking for a function that's got an absolute value in it. And it's J, is that a J?
Yeah.
J of x?
Yes.
All right, which leaves these two A and B's. Now, let's talk about something. When you have a quadratic, there is only one peak or one valley. A parabola either looks like that or it looks like that, with those going to infinity. Okay? You don't have two. In other words, you don't have curvature like that in quadratics, ever. They're always parabolas. where you have curvature is with higher degree polynomials. In fact, the number of peaks is always one less than the degree of polynomial. That's why with a quadratic, we only have one peak.
Okay.
With cubics, a cubic will usually look like this, where I have a peak there and a valley there. They're called extrema. And there can only be two of those in a cubic function. All right?
Okay.
Now, cubics that are at the origin look like this. They don't actually have a loop. They just go through the origin and up like that. Okay? That's flat there, but so if this is y equal x cubed, that's one of the 10 elementary functions that you really should memorize what its graph looks like. I don't know if you've covered that in algebra yet, where they give you the 10 elementary functions, and they want you to know the graphs of all 10 elementary functions, because most other functions can be transformations of the elementary function.
Okay.
Now, do you know what I mean by transformations? Where you have vertical shifts, horizontal shifts, reflections, vertical stretches, horizontal stretches, things like that?
Yeah.
Okay. Well, if I were to look at f of x that has x cubed plus 5 and want to draw that, y equals x cubed plus 5, it would be my black curve shifted up by 5 units. Okay?
Okay.
So that point that is at the origin right now is going to come here. So the curve is going to look like this. Same shape as my black curve, exactly. I have not changed the shape of it, at least I didn't intend to. But the whole thing is moved up by 5 units. And the closest thing they have down here to looking like this is A. And notice that they don't put an XY grid on any of these shapes. So I can't really tell the difference between x cubed and x cubed plus 5. The shape is going to look the same. If you don't put a grid on there, then it's going to look like that. And the only difference is shifted up by 5 units. Well, that could be shifted up by 5 units. I don't know without a grid. So that has to be f of x, A. Now, why does B look different? The only thing left for B is k of x, which is also a cubic. But notice k of x is equal to 5 minus x cubed. Well, what that minus sign does is reflects it over the x-axis. So if I wanted to draw just, let's say, y equals negative x cubed, well, I would take my black and reflect it over the x-axis, so it would look like this, right? In other words, by having a negative sign, it changes the orientation of the curve. Looks more, if I were to turn it on its side, it looks more like an S rather than a backwards S. Well, again, what they've given us for k of x is, I can just write it this way, minus x cubed plus 5, which means my red line shifted up 5. So it's going to look something like that. And that is B.
Okay.
Notice the difference between A and B. B is a reflection over the x-axis of A. That's all it is. And you get that reflection because there's a negative sign in front of the cubed variable. Whereas f of x had a positive sign in front of the cube variable.
Okay.
Okay. Oh, good. I'd be disappointed if you didn't get a little statistics because every student I have from algebra to pre-calc is covering statistics right now, and they have been for the last 2 or 3 weeks.
Okay.
So I'm almost surprised that Evelyn is doing statistics right now. I figured that if anybody was going to have a different curricula this week, it would be Evelyn. And they did. It wasn't all statistics, where everybody else is all statistics.
Okay.
All right. A histogram looks like this, right? In other words, it's a bar chart.
Yeah.
Okay. Well, what they mean when they say make a histogram using 10-point intervals that show the frequency distribution of the scores, well, it's not the one I drew, but first of all, we have to figure out what the frequencies is going to be of each bar. And they have suggested we use 10-point intervals. Well, these are golf scores. So what's the lowest score up there? It looks like 77?
2.
No, 72.
Yeah.
All right, so let's make this the 70s. These will be 80s. These will be 90s. These will be hundreds. Notice that there's a 10-point interval for each one. So how tall is the histogram going to be for the scores in the 70s? Count them up. We got 1, 2, 3. So it's going to be 3 high. And that's how you, that's how you do histograms. How many in the 80s? 1, 2, 3, 4, 5. I get 5. Okay, so that one goes up to 5. So that bar, still 10 points wide. In other words, this covers all scores in the 80s, and there was 5 of them. So that's all we're doing, and we're going to do it for 90s, 100s, and let's see, what's the biggest score here? There's 113, 113, 111, 116, 116. So we need this third histogram to cover the 100 and teens.
Okay.
And I presume the rest of it you know how to do.
Yeah.
You know how to do the 90s, the 100s, and the 110s.
Yeah.
Okay. We won't waste time doing that. Bob's last 11 golf scores were those. Find the range, mean, median, and mode. What do you have to do before you can do that?
Put them in order.
Yeah, so let's put them in order. What's the lowest score? 76. And then there's a 79. And then there's an 80. It's only 180. Yeah, and then there's an 81. And then there's 2 81s.
Yeah.
And there is 182. And it looks like there's 1, 2, 3, 4 84s. 84, 84, 84, 84, and what are the last, whoops, I was getting ahead of myself. I think the next score is 87, is it not?
Yeah, I think that's it.
Yeah, 87. Is that 11? It's usually a good idea to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because if I'd have come up with 10, then I would have known that I missed one. And it's pretty easy to miss one. It's not easy to arrange a long list of numbers in order. It just isn't. It's really easy to make a mistake. Now, the three things they wanted were range, mean, median, and mode. What's the range?
11.
Range is the distance between the lowest and the biggest. Oh, that is 11. Excuse me. Okay, so the range is 11. What's the mean? How are we going to get the mean?
You add them all up and you divide them by 11.
That's right. And that's just an exercise in arithmetic.
Yeah.
We'll just write it as the total divided by 11. Okay. What is the median?
82.
Yeah, it's the middle.
Yeah.
And the middle one is the sixth one out of 11. If I took off the 87, what's the mean or the median?
81.5.
Okay. And what's the mode?
84.
Well, you're no good. You're no fun. You know all this stuff.
Yeah.
Okay. What else? Do we have anything else to cover?
No.
That's it? Okay. Well, we'll just call this a half-hour session then. And
okay.
That's all I'll bill your mom for is a half hour. And that's the way I always work. If you schedule an hour session and you end up only needing 40 minutes, then I'll just charge you for 2/3, or 30 minutes, half, or 20 minutes, I'll just charge you for 1/3. So we don't need to just go for an hour for the purpose of going for an hour. If you're done with the material that you need to cover, and I would say you know it awfully well. I would expect you to do quite well on this test tomorrow. Because I remember you knew the first page pretty well also.
Yeah.
Only things maybe are memorizing these two formulas for the volume of a sphere and the surface area of a sphere. They didn't ask for surface area of the pyramid, did they? Okay.
No.
That's good, because that would have been harder to come up with. The surface area of the pyramid depends on the slant line on one of those sides, and they don't give us that, so we'd have to figure that out. But.
Yeah.
All right, Janessa, I will talk to you next time.
All right, yes, thank you.
You're welcome. Bye-bye.